Hello, here is a fun video. Um, we're going to figure out a formula for finding the vertex. And the way I want to approach this is if we're given a particular quadratic equation like this with particular values of a, b, and c, so maybe you have y equals 3x squared plus 7x minus 3 or something like that. So given those numbers, those like whatever they are, how do you find what I call xv, x sub v with a subscript of v, the x coordinate of the vertex? And there's some things I want to, well, let's look at our little parabola exploring app over here. Whoops, here we are. So you can see that if A changes, the vertex goes in different places. So like if A is 0.25, the vertex is over here. And then if A is 1, the vertex is over here. And if A is negative, the vertex ends up all the way over here with totally different x-coordinates. And when B changes, that also changes the x-coordinate of the vertex. And when C changes, what I notice is that the vertex goes up and down, meaning it will have a different, the y-coordinate of the vertex will be different depending on what C is, but the x-coordinate is the same. So again, if I have a different A and a different B over here, here it looks like the x-coordinate of the vertex is 2, and as C changes, that doesn't change the x-coordinate of the vertex at all. This just shifts the whole thing up and down. So that's the first thing I notice here, is that C does not affect the x-coordinate of the vertex, but A and B do change it. So our formula is probably going to have A and B in it, but it's not going to have C in it because C doesn't matter here. So what I want to think about is, what if C is just 0? So because C doesn't matter here, we could just say C is 0, and let's just find the vertex of this particular one. And the way I'm going to find the vertex is just remembering, here's a graph of something that might look like ax squared plus bx, is remembering that the vertex is halfway between the x-intercepts. So if that's an x-intercept and that's the x-intercept, the vertex is going to be, the x-coordinate of the vertex is going to be halfway between. So we should probably find what those intercepts are. What are the x-intercepts of this? To find those x-intercepts, I'm going to plug in y equals 0, and you get an equation that looks like this. And if you want to solve this equation, we could take out a common factor of x from this and rewrite it as x times ax plus b, and then see what are the values of x that make each of these factors equal to 0. This factor here is going to be 0 when x is 0. This one here, if you set ax plus b to be 0, you can then subtract b from both sides. Ax equals negative b, and then you can divide both sides of that by a, which gives you just x equals negative b over a. So if we wanted to find the point halfway between those, the way to find the point halfway between 0 and negative b over a is to get the average of those two things. So you can add them up and divide both sides and divide it by 2. That's the average of those two numbers. So we can then simplify this. You got negative b over a, and then that is all over 2. You could, to simplify this, I would multiply both sides by a, because you can always multiply both sides of a fraction by the same thing, and times a divided by a cancels out there and gives you just negative b, and in the denominator you get just 2 times a. So in other words, the x-coordinate of the vertex is always negative b over 2a, and that is a super handy thing. And then how do you get the y-coordinate of the vertex? take this number, whatever it is, and just plug it into the original formula, and that will tell you the y-coordinate of it. Now in the next video we'll just do a couple examples of this, and then you'll get plenty of practice on the problem set later.